Hello and welcome back to pre-calculus review. This is the trig review, trig part. Part 2 on the video, but still part 7 in the notes, whatever, just to be confusing. So, defined the basic trig functions, talked about angles, figured out the measurements of angles between degrees and radians, talked about the going around the circle a few times and reducing the angle to equivalent angle. And now, before we start working with trig functions, I want to talk about one more necessary thing, which is reference angles, and this is extremely important. So, reference angles. Once you strip down multiple rotation angle to a single 0 to 2 pi measurement, you can reduce the angle further to collapse it to a value from the first quadrant. Remember that the chart that I gave you of values only contains 0 through 90. I can reduce any angle you give me, doesn't matter how large or small or positive, negative, whatever, to 0 to 90 equivalent. So for that we use reference angles. We first remember from algebra that you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So these are the quadrants that you learn in algebra when you divide your XY two-dimensional graph. You get these 4 quadrants, and again it's counterclockwise, the same way we measure angles and everything else. So now we use that. So step number 1 would be to first reduce your angle using periodicity by subtracting 2 pi or 360, depending which units you use, to reduce the angle from multiple rotations to the first 0 through 2 pi. And then you can reduce it further using reference angle. Now, what is a reference angle? Reference angle, let me write so. Reference angle is the angle 0 less than theta less than 90 degrees. 0 degrees less than theta less than, oh, well, actually equal signs there as well. Measured between a ray of the angle and the closest part of the x-axis. Now this might not mean much until we draw pictures and understand. So say you have angle here. This is your angle alpha that you are given. The reference angle would be this one. So this would be your theta. And as you can see, the measurement of theta is whatever this value is. Let's say 45 degrees. If you have angle here, and again, black is the original angle given, reference angle is the ray and the closest part of the x-axis. So this would be your theta. We're going to do many examples here just to make sure. So let's say this is your given angle. Then your reference angle theta is here. Clearly, if it's in the first quadrant, the reference angle and the angle are the same thing. So we use it only for the 3 quadrants where it's different. So say you have 5 pi over 3. 5 pi over 3. What is the reference angle? All right, let's do it. We have our circle, and we have our pi over 3 situation. So this is pi over 3, 2 pi over 3, 3 pi over 3, which is 5, 4 pi over 3, and 5 pi over 3. So angle alpha that it's given to us is 5 pi over 3, which is the black angle here. Right? That's the 5 pi over 3. So it's all the way around the circle, and then weights there, 5 pi over 3. Reference angle is the ray of the original angle and the closest x-axis, which is this. Now, we know that this part is 2 pi. You subtract 5 pi over 3. So that's 6 pi over 3 minus common denominator, right? 5 pi over 3 gives us pi over 3. Now, you actually don't have to do this calculation because you see the answer when you draw. You see it's pi over 3. So I reduced the entire angle down to the reference angle, and that angle is pi over 3. So, again, the given angle to me is the obtuse angle, so this angle here, right? Bigger than 90. You have this angle here as the given angle, but the reference angle is this ray to the closest x-axis, which is this one, part, right? You have a positive part and a negative part. And that's the reference angle. The problem can be far more complicated than this. So let's say you have 129 pi over 3. So that's alpha. First, use periodicity to get rid of extra rotations. And then we'll use reference angle to collapse it to the first quadrant. So first use periodicity. Since I have denominator 3, well, let's just use, I can just use 3 implies that we are dealing with that the 2 pi in terms of a 3 will be 6 pi over 3. So 6 into 129 is going to go 21 times. Right, that's a 12 and then nothing there, and then there is a 9. So, and the remainder here, so minus 6 is 3. So we have 6 full rotations, oh, sorry, 21 rotations, plus 3 over 6 of 2 pi. So this is like 1/2 of 2 pi. Oh, this ended up being 180 degrees. Not happy. Not a greatest problem, but that's okay. Radians. So pi radians. So we're done. I mean, there's nothing. It landed on the x-axis, so we are using 0 here. So our problem, our angle is right here, and it's easy to use. So, wow. Let's pick something else. How about 127 pi over 3? That should be nicer. If I use 127 over 3, That's the same as 21 rotations plus, and now remainder would be 1, right? So it will be, remainder is 1 over 6 of 2 pi, and that 1 over 6 of 2 pi is 2 pi over 6, which is pi over 3. So now my unit circle and we end up at pi over 3. So the original angle will go be, right, 21 times and then add there. The reference angle simply says this. So you have alpha to be 127 pi over 3, but you actually work calculations with theta pi over 3. Very, very easy to work with pi over 3 rather than any degrees or anything like that. Let's see another one. Say that alpha is, so the angle given to you is, I think 31 pi over 6 would be good, I hope. (31/6). So 2 pi in terms of sixes is 12 pi over 6. So this is where you literally can subtract, right? Minus 12, and then the leftover. But you can say 12 into 31 goes twice, give you 24 over here, and the answer is 7. So we have 7 full revolutions plus 7/12. That's what I said. Please pay attention. It's clearly 2. Look, it's 2. Right? Thank you. So it's 2 full revolutions with a 7/12 of 2 pi remaining. Right? So that's 7/12. 2 and 12 cancel, so you have 7 pi over 6. Now this is something that we can draw nicely. So you have your unit circle. This is your 0 where we start our life. And then we know that 7 pi over 6 is here. So this is what I'm going to do. 1 full revolution, 2 full revolutions, and then 7 pi over 6. So alpha is 31 pi over 6. Theta, which is the reference angle, you go to the closest x-axis which is there. How much is theta? Nope. It's just the red part here. Oh, come on. And when it starts, these things, it starts erasing things that I'm not sure if I can just... Yeah, it saves automatically, so I can't even hit save on my own. So it's pi over 6. closest x-axis is the negative part of it. The ray is right there, and the difference between the two is pi over 6, because each pizza slice here is pi over 6. You start with 0, pi over 6, 2 pi over 6, which is pi over 3, pi over 2, and so on. So each pizza slice is pi over 6, and you see there is exactly one pizza slice between the closest x-axis, which is this one, and again, we're not at trig yet. We are still working with angles so we can deal with the trig. Let's do another one of these because you love it so much. Let's go with 17 pi over 3. You know, try this one on your own. 17 pi over 3. So strip extra revolutions off first, and then try to find the reference angle going to the closest x-axis. What are you supposed to divide 17 by? I just want to know the number. Nope. 6. By 6, because 3 are the divisions in the upper half of the circle. So you have 3 up, 3 down. That's 6 divisions for the full circle. Right? If pi is cut in thirds, pi is only half of the circle. So you're dividing 17 by 6. Right, so since denominator is 3, that means that the top part of the circle, 0 to pi, is cut in 3 pieces. If the top is cut in 3, then the same 3 pieces on the bottom, the full amount of pieces is 6. So the full is 6 pi over 3, full circle is 6 pi over 3. Therefore, 17 pi over 3 is divided by 6 pi over 3 to get the full revolutions. So 6 into 17 goes twice for 12, and the remainder is 5. So what do I have? I have 2 full revolutions plus 2/5 of 6 pi over, well, of 2 pi. That's what I said, 5/6. Please pay attention. Of 2/5. I can't even speak anymore. Reset. 2 full revolutions plus the remainder is 5 over 6. This is 2R5. Remainder is 5. So 2 full revolutions plus 5/6 of 2 pi. This is where a 6 and a 2 cancel, and we are left with 5 pi over 3, which is this location, which means the reference angle is here. So alpha, 17 pi over 3, reference angle theta is going to be pi over 3, because each pizza slice is pi over 3. Yes. 5 over 6 is the remainder when we divided the 17 by 6. So that's what we have.
Go over just how you come up with origin points in a circle again. Like I understand that 0 is 2 pi and then the opposite point, but how do you get to the 5/3?
Oh, that's what we did, because I said you look at the denominator and it's 3.
Scrapping it out, like on the circle,
Mm-hmm.
like when you're doing the actual circle.
So this is 3, right? That's a 3. So denominator is 3. That means that the pi is cut into 3's. So this is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and then 6 pi over 3, which is 2 pi. So you just go counting around. You look at the denominator first, and you go counting around. Let's do one more. Yes?
So basically what you're saying is, in order to calculate what you have to divide by, like for instance, in order to get to 6, you're looking at the pi as if it were split into 6.
Yes.
But when you're actually calculating to see where the reference angle is, you're going to the original of cutting it into 3.
Yes. Well, no, you're cutting into 3, but it has 6 pieces because the full is 2 pi.
Mm-hmm.
Think of it that you can never buy 1 pizza. You can always buy 2 pizzas. Right? So, I don't know, shoes. You always buy 2 shoes. You don't go buy 1 shoe. Right? They're even selling 1 shoe. So you buy 2 shoes, right? So this is always as 2 pi. The denominator here cuts pi into this amount of pieces. But then you have the same amount of those pieces on the bottom, which makes it a 6 because it's 2 pi around. Right. So that's the only part. But then when you look at the reference angle at the end, you look at the same number. 3.
Right, so that's what I'm saying. You're looking at how many, the denominator being a 3, you're looking at how many slices. You're not going to the original of having 6 slices on the top and 6 slices on the bottom.
You actually have 3 slices on top and 3 slices on the bottom, which is 6 slices altogether. There are never 6 slices on top now. It's 3 in this particular problem.
You're only counting that against the x-axis. I guess that's why I got confused when I was charting it, because I was looking at the y-axis too.
Never. Y-axis, nope, 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 nope. X-axis and you're done. Yep.
You don't count the y-axis point, you only count the x-axis point.
True.
You would always count that x-axis point.
X-axis.
Your graphing, so you want, pi 3,
Well,
pi over 3, 2 pi over 3.
3 pi over 3 is pi.
Yeah, 3 pi over 3, and then 4 pi, which is 3 pi pi. But you didn't do, I see.
Yeah, I didn't do 90 this case because I didn't, because 90 is going to cut right there, and that doesn't give me, it doesn't work with thirds, right? One more. Can anyone give me a 3-digit number?
111.
Perfect. Pi over 4. Go. And then we have to move on after that. What am I dividing by? 8. So the circle will cut, this is the large pizza pie, right? You cut half, half, and then those quarters. So we have 8 into 1, 1, 1. You can use calculator if you want to, but 8 into 11 goes once. So minus 8 gives it 3, so 31. And it goes 3 times, just one short of 32, right? So it goes 3 times for 24, and the remainder is 7, so R 7. So we have 13 revolutions plus 7/8 of 2 pi, 7/8 of a full revolution. So we have 13 revolutions plus, and the remainder over here is 7 pi over 4. 7 pi over 4 is here because you go pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and finally 7 pi over 4 to go back to 8 pi over 4, which is 2 pi. So we have to go 13 times around the circle and end here. So we'll go and then end there. But our reference angle is to the closest x-axis. And I mean, the reference angle is very easy for pi over 4. It's always pi over 4. It can't be anything else. Because in all quadrants, Anything lands on pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4 is always pi over 4 away from the closest x-axis part. So alpha, given as 111 pi over 4, yields reference angle theta of pi over 4. Now we need to marry all of this to trig. We need to deal with not just reference angles with trig, but we also need to deal with periodicity with trig. So there's a lot of stuff to connect here. The first order of business is this chart. All students take calculus in Hong Kong. So this chart helps you remember the signs that help with the reference angles, because sine and cosine functions in different quadrants have different signs, and I'll show that on a unit circle. So I'm looking over here for unit circle good picture. You can obviously find this and print. If you type unit circle in Google and you go to images, this is what happens. So, you know, pick your favorite color. I am going to use the first one. It has reds and blues, so I just need to see if I can get it to be. Let's. Terrible. I should have seen that it's some transparent. Yeah, we're going to use. How about this one? Oh, actually, wait. You go to Tools, Size, Large. There we go. And then you pick. Ooh, look at this one. Has everything has degrees and. Terrible graphics, but still, there we go. All right. Welcome to Unit Circle 101, right? Overall information, right? Overload. This is everything we learned so far, crammed into one picture. Layers upon layers upon layers of stuff that we did, all piled up in one spot. Okay. 30 degrees. I hate that it doesn't have these lines, but deal with that. The line going into this point here is 30 degrees, which is pi over 6. You want degrees, you want radians. They're there. Sine is 1/2 cosine root 3 over 2. These points are all cosine comma sine. All of them around. So you know how you have x comma y? Now you have cosine comma sine for these points. So now, cosine of 30, root 3 over 2, sine of 30, 1/2. Cosine and sine both root 3 over 2. Cosine of 60, 1/2. Cosine of sine of 60, root 3 over 2. Sine and cosine. Cosine is 0 at 90. Sorry, cosine is 0 at 90, and sine is 1 at 90. All of the values we learned. Now, observe what happens when you jump to the next part. The next part, oh, by the way, the only thing that I would add to this, all students take calculus. That's it. And then you have everything we talked about in one spot. Now look what happens here. 120 degrees. Now look at 120 degrees. 120 is 2 pi over 3, and look at the values. They're the same as it's, because it's a reference angle. Reference angle is pi over 3, and this is pi over 3. So reference angle. Any of these reference angles that go pi over 3 have the same point. Here's your pi over 3. Here's your pi over 3. Here's your pi over 3. And here's your pi over 3. All of these are the same. The only thing that is different are the signs in front of them because they're in different quadrants. And you determine those signs through all students take calculus. It takes some time to kind of unwrap this, but it is very structured. If you go around the circle, same values show up every time. Now, what do you know? If in this quadrant you have a point 1, 1, well, this quadrant has negative 1, 1, negative 1, and 1, negative 1. And that's exactly what's happening with all of these. You see, this is like below y-axis, below x-axis, so all the y's are negative, and x's are still positive because it's positive x. Both are negative in this quadrant because it's below x and beyond y. So negative, 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 negative. It is a very structured, very structured. Where's my microfiber cloth? There we go. Once I called it a rag, I almost got killed by the vice president. No, it's not a rag. It's a microfiber cloth. It's like, okay, fine. What happened?
At my job, yeah, I was cleaning some mirrors, and I was about to use that to clean the mirrors.
Yeah.
That's steel or whatever. Really?
Can't call it a rag, right?
Mm.
It's the next level in cloth. Okay. I would highly recommend that you print out this thing and then stare at it for like an hour. What you can do is you can make posters of this and hang it all over the house. And what you can do, you know how there's a makeup thing when you open it up and there's like a powder thingy and then the mirror? Glue it over the mirror. Right, so you open it like that, unit circle right there. No matter what you know, where you look. You open the fridge, unit circle inside the fridge. That's right. Obviously, you laminate one of these copies because as you're taking a shower, the paper will get wet and bad. So a laminated copy will actually, right? You can make a necklace with it, right? Say to my students, whatever you permanently tattoo on your body, you can use on the test. So if you tattoo the unit circle over here, there's really nothing I can do. I mean, can't go scrape it off, right? You tattoo it right here, unit circle with all, like the whole thing. Permanent ink, I mean, you know, it's nothing I can do. So, I mean, we bet to put it on the forehead because you can't see it, right? Unless you know, talk, like two people talk, and then you both do it, then you can, right? But then someone will think you were in a cult or something. So that's one way to see it all the time. Another thing that you could do is to type in Google, if I still have it, type in the Google blank unit circle, and that comes up with this. And you know what you can do with this? Yeah, you can fill it up. So print about, 17 to 25 of these. And then you go and you write on it. You know, first 2 times you kind of compare it to the one that you see, and then you start. Now, if you start doing that, you will see the mirroring, and you will see amazing thing happen. You see these mirrors. You can't see that if you just try to learn. But if you go like this, ooh, that's the same, and then that's the same, and that's the same, and that's the same. All of these have the same numbers. Those 4. They create a rectangle. Now go to the one inside. Look at that. All have the same. So as you are mirroring numbers like a mirror. For x-axis and a mirror on the y-axis, both of those, your mirror, and you just be careful, oh, this quadrant has negative x's, All of the x's are negative. These ones have positive y's, these ones have negative y's. So positive x's, positive y's, negative y's, and all the same values. Are you going to remember the whole circle? Hell no. All you're remembering are these. And the reference angle collapses all of those values, which is the reason why I gave you the chart I gave you. The chart only addresses 0 to 90, which is the first quadrant. So if I ask you about 210 degrees, you know that 210 degrees is the same as 30 degrees. Both negative. And we are going to practice that skill now. So now we are going to practice use of reference angles in conjunction with calculating trig functions from the chart that you should be able to construct in 18 seconds. So I go back, and now I want to calculate. Oh, all students means sine, cosine, tangent are positive. Sine is positive. Tangent is positive, and cosine is positive. The rest is negative. That's what it means. All students take calculus. All sine, tangent, cosine. ASTC. So now, say you want to compute tangent of 107 pi over 6. That's the goal. Tangent of 107 pi over 6. You first do the reference angle, which is the procedure we did 15 times over here. We have 107 pi over 6. Over 6, that means 12 pi over 6. So 12 into 107 would go 9 times. 9 times 2. Oh, it's going 8 times, right? 8 times, that's a 96. And that gives me 11. So R, 11. So what do? I say, ooh, I forgot to tell you about even and odd functions. I'll have to do that in this problem. So we cross out this 8. No one cares about 8 revolutions because it's the same spot on the unit circle. All we care about is 11/12 of 2 pi. So we are dealing with 11/6. So tangent of 11 over 6 pi. 11 pi over 6, whatever. So this is the same. Angles are not the same. But the result of the tangent of those two angles is the same. Because it's in the same location in the circle. You draw the same triangle, it has the same ratios. Now, we are still not happy with 11 pi over 6 because 11 pi over 6 is not on my 0 to 90 scale. In the unit circle, 11 pi over 6 is one short of 12 pi over 6, which is right here. And you see the reference angle is pi over 6. And now here comes the $1 million step. Tangent of 11 pi over 6 is equal to negative tangent of pi over 6. And now you're going to go, why negative? All students take calculus. All students take calculus. Tangent is negative in the fourth quadrant, and your angle is in the fourth quadrant. The 11 pi over 6 in the fourth quadrant. 7 pi over 6 is in the third quadrant. Pi over 6 and pi over 3 are in the first quadrant. So it's going to land in one of the four quadrants. So negative tangent pi over 6. We know from the chart that tangent of pi over 6 is root 3 over 3, so the answer is negative root 3 over 3. And there you go. So what is the tangent on 107? Pi over 6. It is negative root 3 over 3. I will do one more, and then I will ask you to do one. So sine of, let's say, 39 pi over 3. That's not good. 39 can be divided by 3. So let's go with the 38. So 38 pi over 3. I immediately divide 38 by 6 because you have to double the denominator for the right top and bottom portion of the thing. So that goes 6 times for 36, and the remainder is 2. We don't care about 6 revolutions. All I care is about 2 sixths of 2 pi. And then 6 and 2 will cancel to give me 2 pi over 3. 2 pi over 3 on the sine. So this is equivalent to sine of 2 pi over 3. Now 2 pi over 3 for the sine is on the bottom. So this one over here is positive 1. The one on the bottom as a... Oh wait, this is 2 pi over 3, not 3 pi over 2. Yeah. Sorry. Yeah, it's on top. Thank you. For whatever reason, I flipped it in my head and it looked... I thought it was 3 pi over 2. It's 2 pi over 3. So 2 pi over 3, we cut the top portion into 3's and the bottom portion into 3's. So pi over 3, 2 pi over 3, and then pi. Now you see that it's in a second quadrant, right? It's a Q2. And Q2 has sine to be positive. So this is equal to sine of pi over 3. And sine of pi over 3, when you read from the chart, is root 3 over 2. So sine of 38 pi over 3 is equal to root 3 over 2. Again, all students take calculus. Sine is positive. The reference angle is pi over 3. Reference angle, closest x-axis. Closest part of the x-axis. So, pi over 3 right there. I'm going to leave this example visible and come up with the cosine of what's going to be bad? Cosine of you know what, let's stay in the neighborhood. It's different enough for you to. It has a different number, has a cosine, so let's see what you come up with. Okay, what am I dividing by? Same thing as above, right? 40, 6 into 40 goes 6, so 36, subtract R4, and that's all we care about, so 4 over 6 times 2 pi. This and this cancels. We are left with over 3. Beautiful. So 4 pi over 3. So we have our cosine of 40 pi over 3 to be the same, exactly the same, as cosine of 4 pi over 3. Now, on the division side over here, we have pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3. We are in the third quadrant. So this is the original angle, and then we have the reference angle theta, which is the red one. But now all students take calculus. It's negative, right? So this is all equal to negative cosine of pi over 3, and the cosine of pi over 3 is 1/2, so negative 1/2. I hope you guys see that you must use the reference angle. Oh my God, it's just so annoying with this disappearing stuff. All right, and that concludes today's lecture. No, it's lecture review, whatever. Let me just shut this off. Okay, bye.